Good morning, students. In today's class, we are going to see how to formulate a linear programming problem. So for this, let us consider example number 1. Let us read it out. What is the problem? It is a product allocation problem. So what it states? A firm manufactures two type of product A and product B, and sells them at a profit of Real 2 on type A and Real 3 on type B. Okay, then each product is processed on two machines G and H. Type A require 1 minute of processing time on G and 2 minutes on H. Type B requires 1 minute on G and 1 minute on H. The machine G is available for not more than 6 hours and 40 minutes, while machine H is available for 10 hours during any working day. How many products of type A and type B shall be manufactured? Formulate the problem as a linear programming problem. Okay, so if you read it at the first instance, you will see all this is a theoretical problem. Okay, everything given is in theory. It's difficult to formulate it as it is. So what we will do, the first thing we should do in this is to store this given information in theory in the form of a table. Okay, once you're able to make a table for it, then it will be easy for us to prepare the formulate the linear programming problem. Okay, so what we'll do, first we'll try to make a table is not difficult, it's easy. Let's see how to do it. So let us read it one by one what is given. So first thing, let us read the first line. A firm manufactures two type of products, product A and product B. So what is it? It is about a firm which is manufacturing two type of products. So let us write here products. Okay, what are the products we are having? It is manufacturing two type of product A and product B. Okay, now what is next? It manufactures two type of products and sells them at a profit of Real 2 on type A and Real 3 on type B. Okay, when firm is manufacturing something, it is to be sold out, right? So it is given that when this manufacturer sells product A, it will get a profit of 2 reals on each item. Similarly, on product B, it will get a profit of 3 reals on product B. So let us write this information here. Profit. Why we wrote profit here? Because it is associated with both A and both B. So for A, the profit is 2 real. So we'll write here 2. Profit, the units is in real. So we'll write it here. And for B, the profit is 3. So we'll write it here. Okay. Let's see what next is given. Each product is processed on two machines G and H. So now since we have two products A and B, both has to be processed on two machines G and H. So for that we'll write machines. Again we'll write it here because it is for both the products. Okay. So the machines are G and H. Now let us talk about machine G. What is given? Type A requires 1 minute of processing time on G and 2 minutes on H. So we are talking about product A. It requires 1 minute on machine G and 2 minutes on machine H. Next line. Type B require 1 minute on G and 1 minute on H. So it is 1 minute on G, 1 minute on H. Now since the time is given in minutes, we will write minutes for both G and H. Now what else is given? It is given that machine G is available for not more than 6 hours and 40 minutes. So machine G, which is used by both products A and B, is available for machine G, which is used by both products A and B, is available for not more than 6 hours and 40 minutes. So machine G is available for 6 hours and 40 minutes. What is given here? And machine H is available for 10 hours during any working day. Machine H, it is available for 10 hours. Okay. So this is how we put the information in the tabulated form. Okay. Now let us see what is the question, what we need to do in this. It is asked, how many products of type A and type B shall be manufactured? So we want to determine how many products of type A, how many products of type A to be manufactured and how many products of type B to be manufactured. Okay, so now to formulate this, since we don't know the number of products of type A and type B to be manufactured, what we will do? Let us, as in maths, we will do assumption. So let us assume that let the number of products of type A to be produced will be, it is denoted by X. Let X be the number of products to be products of type A to be produced, and let Y denotes the number of products of type B to be manufactured. Now it is, as in formulation, the first thing we should have is having an objective function. So just write first objective function. Objective function. So as we know that objective function is always associated with optimization problem. So it can be either maximize or minimize. So what is given here? It is, we can see from the table, profit is given here. So it's the aim of every manufacturer is to maximize his profit. So we'll use this as a objective function. Now see what is given. On one product of type A, the manufacturer will get 2 reals of profit. So if on one product of type A, how much profit the manufacturer is getting? 2 reals, right? 2 reals. Now, if suppose the manufacturer will produce 2 products of type A, how much will be the profit? If on one product the profit is 2 products, it will be 2 into 2. Similarly, if it is 3, then the profit will be 3 into 2, right? The number of products into the number of amount of profit. Now what is given here? That we are assuming that X is the number of products of type A to be manufactured. So similarly, for X products of type A, the profit associated will be 2 into X. Okay, that is, we will write it as 2x. Similarly, what is given? On product of type B, on one product of type B, the profit is 3 reals. So how many products we are manufacturing? The manufacturer decided that it will manufacture Y products. So the profit will be 3Y. Okay. Now the total profit for the manufacturer. Total profit comes from the profit from product of type A plus the profit on product of type B. So profit on product type A is 2x and on type B is 3y. So the total profit is 2x plus 3y. Okay, so we denote it as, say, Z. So the objective of every manufacturer is to maximize the profit. So we'll write maximize Z equal 2x plus 3y. This is our objective function, the very first thing that we need to get in a formulation. Okay, now next we need the constraints. So to get the constraints, what we'll do, we'll use the remaining data given in the table. So in the table, what is given? Machine G is working on machine G. Type A product required 1 minute, type B required 1 minute. Okay, and total availability is given in 6 hours 40 minutes. So what we can see from here, here the information is given in minutes and here it is given in hours and minutes. So it's better to convert everything in a single unit. So what we'll do, 1 hour, we know that 1 hour is having 60 minutes. So we'll convert 6 hours into 60 minutes. So 6 into 60 plus 40. So it will give you 400 minutes availability on machine G. Similarly, for machine H, we'll make it at 10 into 60, that is 600 minutes. Now we have all the units in the same, so we'll do it. Now, if one product of type A require 1 minute on machine G and one product of type B require 1 minute on machine G. So X product require X into 1 minute plus Y into 1 minute. And the machine is available for maximum of 400 minutes. We cannot use it for more than 400. So we'll write it less than equal to. Similarly, for machine H, one product of type A require 2 minutes on machine A. So X products will require 2 minutes, 2x and y into 1. And this machine is available for not more than 600 minutes. So we'll get the two constants, x plus y less than equal to 400 and 2x plus y less than equal to 600. This is the second thing we got. Okay, what's next? Since x and y denotes the number of products to be manufactured, x and y are number of products to be manufactured. So any manufacturer cannot produce negative number. Okay, they either manufacturer will product no product at all, or it can be more than one. So we'll have the restriction, x should be greater than equal to 0, y should be greater than equal to 0. So if we combine all this together, we'll get our linear programming problem. So what is it? First is the objective function. So the formulation will be, so what is it? See here, maximize 2x plus 3y. So maximize the objective function 2x plus 3y, which is subjected to the constraints that we got from here, from machines. X plus y less than 400, 2x plus y less than 600. X plus y less than equal to 400, 2x plus y less than equal to 600, with non-negativity restriction that x and y should be greater than equal to 0. We can combine these two together. So this is our formulation of the given problem. Got it? I hope it's clear.